Hello, we're going to continue working with Newman projections. It's something that is a molecule here, 3D. We're going to be looking at the molecule this way. So see that one carbon atom in black is eclipsing the other carbon atom in the back. So we're going to be doing drawings in this screen, which is 2D, but understanding how do we translate something that is 3D into 2D. So let's start doing Newman projections. So this is about solving those type of problems. So I'm going to draw now. The first molecule that we're going to draw here is, let's draw the carbon this time explicitly. This is a type of projection, the sawhorse. And so it's somewhat of a perspective. If we are here and we tilt it a little bit. So this is what I'm drawing now. So this would be one of the carbons. Here, this is an H, and I'm going to make this longer. Now I have a chlorine, an H, and a bromine. So this molecule, imagine that I'm looking at it this way where my pen is, right? So now I'm going to draw that on the Newman. My view is where my pen is. So this carbon is going to be in the front. So let's do that. And I'm going to draw a circle to represent that carbon in the front. So now looking at it this way, this line has vertical is a chlorine. Now again, looking at it that way, I see that the H is in this direction, right? So I'm simply finish the rotation, let's say. So now I have an H here and a bromine on the other side. Now, again, we go back to this. This view, this chlorine is actually eclipsing the metal in the carbon in the back. So we're going to draw it this way. And now this metal is being eclipsing with the hydrogen and the carbon in the front. And here I have a hydrogen. And as I was saying, this is not only a Newman projection, but this particular conformation we're going to say is eclipse. That's an eclipsed conformation. It is not the lowest energy conformation. So we're going to take advantage of that to draw a structure that is better than that. And so to do this, I am going to make a rotation. And let's say that this, I'm going to put it over here. I'm going to do say 30-degree rotation. Remember, if I draw here my circumference, and I'm drawing these 3 lines, right? So the angle here is approximately 120. Right, so half of that, I'd say around this is half of that rotation. See, so this is what we're doing. This rotation, 60 here. So now I'm going to redraw the same. And I said that I'm rotating the carbon in the back. So I'm keeping the carbon in the front the same. I had an H here and a bromine. And when I did that rotation, then the metal is now here. And there's one metal here, right? So now the second metal went over here. And I have the hydrogen here. So notice I have metal, metal, hydrogen, metal, metal, hydrogen in the back. But now this conformation, and we mentioned in another video, is called staggered. And these conformations are lower in energy than the eclipse. We don't have those interactions, steric interactions, which contribute to something that we say strain energy to that. So now torsional strain. Now this, again, this is the view exactly as it is from this point of view, in the chlorine on top, in the metal eclipsing, but that was a higher energy conformation. That's a lower energy conformation. In taking advantage again of what we have in a concept that we said before, these two the chlorine in the front, in this conformation, the metal in the back, are at 180 degree. So we say those two are anti. And when things are a different conformation, say that they are not 180, but at 60, we say that's gauche. But this is of the staggered, the anti-conformation. We're going to continue doing more problems of Newman projections.